Alright, so I have some black background here, and I'm gonna place my cut up to fit the size of the cover on top of this exactly, and line up my cover so that it lines up on the right, it lines up on the left. Excuse me for a sec here. So hide the Tengu tissue, you don't want to see it here. Okay, hide this Tengu tissue too, this one too. Now we can place it on this edge. There we go. So now we can take a picture of this and then place it on Photoshop, and the rest of the exercise to figure out how much furnish we need to add to the loss area will be done with Photoshop, right? I took the weight of the cover already, it's 7.9 grams. And from that and the area of whatever cover left, we should be able to figure out the grammage of the GSM. And from that, we can figure out how much furnish, the furnish I made, we can add to fill in the gap in between, right? So that's what it is. So to do this right, I need, of course, to reposition this right, because I just moved it. Everything's so delicate with this hobby, I tell you. Everything. Okay, I need a square centimeter, and this is a white square centimeters that I'm going to place here to the side. It's going to be part of the picture I take for Photoshop, right? Here it is. It's 1 centimeter squared. All right. Should I take a picture now? I think I can. Okay, here we go. All right. See you guys on Photoshop. All right then, so we have here the outline. You can see it of the top. And we have this 1 squared centimeter. I'm gonna start off by selecting all the black areas by clicking the Shift key and the magic wand. Magic wand, you can set it to about 14 for tolerance, and you can go ahead and select these big areas within Photoshop, including anything that you might miss. And let's see, like here, for example, right? Okay, and I think this area here, by extension, this area here, and then this area. Yeah, these marching ants everywhere, right? Tells you that things have been selected. Oops, I undid the deselect, so I'm gonna redo it again. Here we go. All right, so we have everything selected except for the cover itself hasn't been selected. So now we're going to go ahead and let's see. Some of the graphic and the front cover have been selected also, which is okay. And we're gonna deselect the 1 square centimeter by including it in the black, basically. So I'm gonna select it also as part of the selection process. Okay, that's good enough. And now we're going to go to select inverse, and that highlights only the cover and will give us the pixels of the cover by going to the histogram function. If you see the triangle with an exclamation point, clear it by pressing refresh, and that gives you the number of pixels of the cover. So you write this down, and now you can get the pixels of the square by itself. So you can highlight that. Gives you 435. So if you divide the pixels of the cover, which are 343980, by the 435, you get the centimeter squared of the cover, current cover. So it gives you the area of the cover minus all the losses, right? All right, let's do that. So if you divide the number of pixels of the cover by 435, you get 790.76 centimeters squared. 790.76 is the area of this cover minus all the losses. Now we calculate the GSM, and the GSM is basically the weight of the cover, and the weight of the cover was 7.9 grams. We multiply that by 10,000 and divide it by the area of the cover in centimeters squared. You get 99.79, so 99.8 essentially grams per meter squared. And actually, this is what I got doing it by hand almost, right? I got 95.76 grams per meter squared doing things by hand, right? So I got the area of the cover to be 825 versus we got 790.75. So very close, right? Doing it by hand or by computer, either way is fine. Okay, so we got 99.8, around there is the GSM. And now, write this down better. And now we have to figure out the area of the loss on the top here. And we can use the magic wand for that. This area here is equivalent to like this area here, so we can stop right there, right? We have some areas here not selected, so we can just pretend this area is all the little selections that I didn't select. So this area here, from here to here, essentially has been selected, and it is 12,276 pixels, right? 12,276 pixels. If we divide this by the pixels of the 1 centimeter squares, which is 435, what do we get for an area? Divided by 435 gives you 28.22. Centimeters squared is the above the front cover, right? All right, so we have 28.22 centimeters squared. Now we're gonna do this area here. So we got this, and this is 3,400, basically, right? 34,000, right? 34,000. So middle is 34,000, and 2 divided by 435 to get the area, and that gives you, which is the area of the 1 centimeter squared, and you get 78.16, which is really bizarre because I got the same number doing it by hand also. You can see it here, right? So I got 78 centimeters squared, so it's very, very close, right? So you can do it by hand, you could do it on the computer, either way. You can confirm it that way, doing it yourself, different measurements, right? So this is the middle. And then there are little areas here which can be filled easily with Furnish, a little bit of Furnish, but let's do this area here. This area here is 1127. Divided by 435. And that will give us, let's do it here, 1127 divided by 435. 2.6 centimeters squared. What did I get when I did it by hand? I got the same. I got 4.5 times 0.5, which is about 2.6, right? Got exactly the same, right? So, and you can do then these areas, right? White. Okay, and this area is about 1 centimeter squared is 444, right? So 1 centimeter squared, let's say. All right, not huge. All right. All right, so to calculate the amount of fiber you need, for example, for the middle here, you take the area of the middle, which was 78.16, and you multiply it by the GSM, which is 99.8, and you divide by 10,000 to convert to meters squared, right? 10,000, and you get 0.78 grams of fiber is what is needed. And interestingly enough, what I got with my calculation was 0.75, right? So you can do it by hand, you can do it by computer. 0.78 is pretty good number here. 0.78 grams of fiber, less than 1 gram of fiber is needed for this area here. And we know that our pulp here contains 1% fiber. So with our pulp recipe, every mil is 0.01 gram of fiber. So if you need 0.78 grams of fiber, you need 78 mils. That's basically how you do it, right? 78 mils of Furnish will go in this area, and that delivers the amount of Furnish needed to satisfy the centimeter squared of this area, which is 78.16. And this area here, which is 28.22 centimeters squared, right? We have to play around with this because some of this went in this way, right? This little area was 1 centimeter squared, basically the same as this. And this little area will require 1 times 99.8 divided by 10,000. Very little, right? then so you need about 1 mil. 1 mil of Furnish will go in here, and that satisfies the area here. This area here, it's an area of 2.6 centimeter, right? Exactly. So you need 2 mils here of my Furnish to go in here. All right, so we'll map it out. I'll write the numbers down and show you how much we need. And so stay tuned. Let me write them down right now so we have them on the chart. So the 78 mils will include all of this area here into down here, right? And then this area here is separate. This is going to be 9690 pixels. We'll divide it by 435. And we get the centimeter squared. Let's see. We get 22.27, 22.3. 22.3 multiplied by the GSM, which is 99.8, gives you 2,223 divided by 10,000 to convert, and you get 0.22 grams of fiber. 0.22 grams of fiber is 22 mils of Furnish. So 22 mils for that area. And from beginning of the S on. From the S on. Okay, so we know. And then this area is 1 mil, and this area is 2 mils, right? So we can write those down. All right, so we got things mapped out here. 2.6 mils for this area. 78 mils goes all the way like this, right? Down. And then this top area here from the S on is 22 mils. And 2.6 mils for this area down here. Right? That's it. So we have mapped out. I'll save the file so I don't lose the data. And we just have to now to do the leaf casting.